In the previous model, which is model 1, we explain the resistive force in with low speed as it's in liquid or gas state. But in model 2, we will explain when object moving at high speed through air, as in examples airplanes, skydivers, cars, and baseballs. In this case, we will see that resistive force is directly proportional to the V square. And its rule is equal R equal half D rho A times V square. And R represent resistive force, D represent drag coefficient or resistive coefficient, rho represent the density of air, A represent area of moving object in plane perpendicular to its velocity, as its area between the plane of velocity and the plane perpendicular to it. Okay, and V represents the velocity of an object. And D is equal to 0.5 for the spherical object and equal D and equal 2 for irregular objects. We can see some examples about the two models or some problems. So as shown, a small sphere with mass 2 kg is moved with initial velocity 5 meters per second in large vessel filled with oil. Determine final velocity when its time constant 3 seconds. Okay. In this example, the body moved in large vessel filled with oil. So we can use model 1, which move with low speed as V naught times E to the power negative B over mt equal V. Okay, this rule is used when the body moves with low speed. And as we given V naught equal 5 meters per second and m equal 2 kilogram, t equals 3 seconds, and p, which is constant, which is drag coefficient or resistive coefficient, equals 3.3 times 10 to the power negative 2. Then we will substitute in the rule, as we note it will be 5. Okay, it will be 5 times e power 3.3 by 10 power negative 2 divided the mass, which is 2, times time, which is 3. It will give us 4.75, which is the final velocity. So the resistive force affects the body to move from 5 meters per second to 4.75 meters per second. So it's effective resistive force, which is held in slow this speed. And the second example is on the model 2, which is move with high speed in air. As shown, if a baseball hit by velocity with resistive force 5 Newton and with drag coefficient, which is the same of resistive coefficient, equals 0.5, this means that the object is a spherical object, as its d equals 0.5. As we said that d equals 0.5 when it moves in spherical object, and with an area in a plane perpendicular to velocity is 4 meter square. And as known, density of air equal 1.2. So as its rule equal R equal half D rho A V square, and as given R equal 5, D equal 0.5, A equal 4, and rho equal 1.2. So we will take root of R divided by half times D times rho times A to get V. Then we take root 5 divided by 0.5 times 0.5 times 1.2 times 4 will give us 2.04, which is the V. So by these two examples and the previous explanation, I tried to explain resistive force.